So the mole is our centerpiece. What is a mole? Let me just start there. It's a unit. Thank you. It's a unit related to a number. Okay, it's a counting unit, like a dozen equals 12 or a ton equals 2,000. So we said that we can go from mass to moles and moles to particles. Was particles the only unit that we talked about yesterday? Particles is very general. What are the other four that are associated with it? Molecules, atoms, formula units or fun, and ions. Remember, that just gives you some insight into what type of substance you have. It doesn't necessarily, change the math at all. Don't get hung up with the units. It just tells you what type of compound or substance. And then over here on the left, we have mass. What's our unit for mass? Grams. That's what we're going to talk a lot more about today. But to go from one to the other, which one of these three is always going to be the smallest number? So we started talking about the end of class yesterday. Which one's going to be the smallest number? Always. Mole, right? Because it's a counting unit. It's related to the other ones that are bigger. They're bigger than it. So we can count by moles. It's something very, very small that we can, manage in a lab setting. And it's related to mass. It's related to the number of particles. We're not going to sit there and count out, 6.02 times 10 to the 23rd particles. We can't do that. All right? It would take forever. So to go from moles to the outside, I'm drawing this a little bit differently than what I did yesterday for you guys. You don't have to redraw it. When we go from the inside out, what mathematical operation do we use? If you just told me that moles is in the middle and it's smaller, to get to the outside has to be right, because it's going to be larger. So we're going to use multiplication, all right, on both sides when we go from the inside out. So to get to particles, what number do we use? 6.02 times 10 to the 23rd. Whose number is that? Avogadro. It's not avocado, but if it helps you remember it that way, Avogadro. All right, and then mass is what we started talking about at the end of class yesterday. What was that term that we used for the mass? Or where did we look to get it? MM. What is MM? Molar mass, okay? Molar mass is one term. It could be formula mass. It could be gram formula mass. That's one that I've looked on some Regents exam questions, and that's one that they use a lot, is gram formula mass. Don't get hung up, guys. It all means the same thing. It's the mass. Where do we look to get it? Periodic table. So have your reference packets out if you don't already have those. You're going to need those today. They all mean the same thing. Now, if we're starting on the outside of our roadmap here, and we're going back to moles, what mathematical operation do we have to use to get to a smaller number? Division. And we're going to divide by those same numbers. So those kind of, I don't want to say constants. Avogadro's number is a constant. When we're dealing with particles of any sort, we use his number. Molar mass isn't necessarily a constant. Why not? Yeah, it changes with what element you have, the size of the atom. We're going to learn today that actually the formula is what we're going to be looking at. So we're going to use that formula from a chemical formula. So that's going to be changing. The idea is stationary, it's constant, but it's going to change based on the substance that you have. All right? This is going to be a useful tool that you want to use not only starting out, but throughout and beyond this unit as well. This is something very small, very simple that you can go back to reference. We're actually going to add another piece to that in February when we do our gas laws. We'll add volume. We're not doing it now because volume is only when we have gases, not when we have solids or liquids. So we'll come back and we'll add more to this in unit 11 or 12 when we do gas laws. All right? So I'm going to kind of be flipping back and forth with this slide as we go throughout some practice here today. So here's our example. Page 3, example number 1. It's asking us how many grams are in 2 moles of helium. What do I need to do with every single word problem that I get? What's the first step I want to do?
Given.
The given, guys. Get in that habit of calling it a given. It's going to make a lot more sense and help us out when we get to stoichiometry after Christmas break. So our given, we have 2.0 moles of helium. It is now important, guys. You cannot just say moles. Okay? You have to put the substance with it. Why? Why do you think it's important to add that to our unit?
Because a mole can be anything, so you need to know what it is.
Exactly. A mole could be anything, so we have to know what it is. Specifically, why else might that be important? Why we need to know what it is here?
So might be dealing with multiple moles and you want to switch them.
Okay, multiple moles of different substances. Absolutely, we're going to. When we get to stoichiometry, we're going to go from one substance to another. Why else specifically in this problem? You guys are both right with what you've said. Why else is it important to put helium here and not just moles? What size changes? The atom, which relates to the mass, right? Absolutely, guys. The mass is going to be dependent. So we're trying to get to grams in this problem. You have to know what substance you have because that's going to dictate your conversion factor. So if we set up our T-chart, I'm going to go back here for a second. What am I given in my problem? What was I given in the other problem that I just had on the other slide?
2 moles.
Okay, so here, I'm right here in the center. I'm in moles, and what am I trying to get to? Particles or mass? Mass, because my unit is grams. So I'm trying to go from here to here. I'm going this way. So follow your roadmap. This is where this becomes a useful tool. What does this arrow say? Oh, to get from moles to mass, what do we have to do? Multiply by the molar mass. Now, if we look at the T-chart method, let your units drive the math. We know that moles has to go on the bottom, and moles and grams are related. All right, so moles will cancel out. Hey, we're multiplying just like it showed. The roadmap, what that helps us say, what number are we going to use? Are we going to use Avogadro's number or are we going to use the molar mass? Well, we're going from moles to mass, so we've got to use the molar mass of helium. We're not using Avogadro's number here. And that's the hardest part for students every year is they just want to use 6.02. They don't want to look it up on their reference packet, on their periodic table, if they're dealing with mass. They just start using that. So as we practice and you start getting into mixed practice, follow your roadmap. Look at your units. Now, when we have a conversion factor like we have here, which one always gets the number 1? Moles, guys. Mole will always have number 1. We're writing out a conversion factor. 1 mole equals something else. It equals Avogadro's number, or it equals a certain amount of mass for our substance. So 1 mole of helium, what's our mass going to be? 4.0026. And do not round until the very end. If you round too early in these problems, you start getting in that habit, when we get to stoichiometry, your final answer could be way off. When we do this math, what do we get? All right, now we'll round. What are we going to round to? Correct sig figs, always. How many sig figs will we round to? Why 2, Jill? Okay, why is there 2 sig figs? What number do we look at? The starting number, okay? That's that y. Always go back to your starting number because that was the original measurement you had. So we're going to round that. So our final answer is 8.0 grams of helium. Easy? All right, absolutely. It's not too bad when you isolate it. Use the T-chart because it's going to help you out. If you have struggled with it all year long, hopefully this is going to start to be easier because we're not using metric system, but it's going to be a tool we're going to use all year. All right, here we go. Example number 2. It says, how many moles are in 3.01 times 10 to the 23rd atoms of silver? What's my first step? Same first step with every problem. Write your given. 3.01 times 10 to the 23rd atoms of silver. Don't get hung up on atoms. It's just letting us know, hey, we only have one substance. We don't have a compound. It's just a single element. Where will atoms have to go to cancel out? On the bottom. So let's go ahead and set that up. Are atoms related to moles? Like, are they? Can we make a conversion factor between atoms and moles? Absolutely we can. So that's going to be on the top part of our new conversion factor. So if I were to go back and take a look at my roadmap, right, I'm starting over here with atoms. I need to get back to moles. So what am I going to use? What number am I going to use? Avogadro's number. Okay, and I'm going to divide to get back there. So my T-chart should show that, hey, I'm going to be dividing it. Well, 1 always goes with moles. Avogadro's number, since we're dealing with atoms or particles, on the bottom. So all we have to do now is do the math. It matters how you plug it in. You all should plug this into your calculators now, because if you have issues with it, now is when I can help you with it. On your quiz, I can't. On your quiz on Friday, you'll be on your own. So our answer here is going to be 0.5 what? Moles. Is that it? Yeah, gotta let me know what it is. And the reason why I want to start driving that home now, again, it's all related to stoichiometry. Basically, guys, what stoichiometry is units 5, 6, 7 all combined into one. Alright, so these next couple of units, it's good to get into these habits now. Take a look at example number 3. Alright, it says, what is the mass of 1.2 times 10 to the 8th atoms of copper? So we're looking for what here? Mass. What are we given to start? Oh boy. 1.20 times 10 to the 8th atoms of copper. This is where that roadmap is really going to come into play. So let's go back and take a look at it and kind of get a mental idea of what we're going to do. Where am I starting when I look at my map here? Atoms, all the way over here to the right. This is where I'm starting. Where do I need to get? Am I just going back here to moles? I need to get to mass. But can I go directly from particles to mass? No. So how many steps is this process going to be? What do I always have to go back to first? Moles, guys. That is the pin holding everything together. You have to go back to moles first. So if you have no idea how to solve a problem, always go back to moles, because you're going to get partial credit anyway for doing that step. Maybe you forget how to do the next part, but if you go back to moles first, no matter where you're starting at, you know you're on the right track. If you go back to moles, you can then go to anywhere. So it's going to be a 2-step problem. Let's take a look. Let your units drive your math. Your units will set up where the numbers need to go. I'm starting with atoms. Where does it need to go to cancel out? In my fraction. Top or bottom? What did you say? Bottom. Right? If it's on the top to start, it's got to go on the bottom. So atoms of copper is going to take me back to moles of copper. Atoms are gone. When I have moles and atoms, which one always gets the number 1? Moles. 1 mole is how many atoms? There you go. 6.02 times 10 to the 23rd. Am I done with this problem? No. And this is where the beauty of the T-chart comes in, with this factor label method. You don't have to stop and do any math here. Keep going. Set it up. Get to the unit you want it to. Alright, so moles of copper on the bottom. I'm trying to get to mass. What's my unit for mass? Grams of copper. Which one gets the number 1? Moles always gets the number 1. How many grams of copper? Where am I going to find that number? Periodic table. Good. What is our molar mass or our atomic mass of copper? 63.5%. Yeah, it is. 63.546 grams of copper. Now, plug it in, and that's all you've got to do. But that's it. That's how we do it, guys. It's a 2-step. We can now go from mass to atoms. Okay? We'll take it a step further in a couple of days once we get, comfortable with it. But follow it. Let your units drive your math. Set them up in the T-chart and it will follow. Even if you have no idea how to attack a problem, everybody should be able to at least write down your given. If you do this with the correct units, correct given, put that 1 and set up your T-chart, I'm going to probably give you on a short answer problem, I'm going to give you at least a point for trying. Okay, you wrote down something, you made an attempt. Alright, so maybe you don't remember where else to go. Take it step by step. Once you have this, look at what unit you're starting with. You never are going to end up with the unit you're starting with, so you should by now hopefully know that, hey, the unit that I have has to go on the bottom of my next fraction.
It's going to moles.
What's that?
It's going to moles and not grams.
Right, I'm not done yet. Yeah, I'm not done yet. So I'm taking it step by step. So we're trying, if we look back at our roadmap, we're starting with grams, which is over here on the left, and we're going back to moles. It's a one-step problem. So this is the path that I'm going to take. I'm going to divide by my molar mass. And that's exactly what we're doing here when we set up our conversion factor, like so. Moles of boron are on the top. Grams will cancel out. Again, I'm going to keep asking it over and over. Which one gets the number 1? Moles. 1 mole of boron equals a certain number of grams. How many grams of boron is it? 10.81. So, let's say you didn't know how to really do all of it, but you had your grams canceled out, top and bottom. Know that, hey, I've got to go to my periodic table. If I put that down with the element that I see, you're probably going to get another point. The more little pieces you can string together, guys, the more potential partial credit you can get to get the most points possible. When I take 11.5 and divide it by 10.81, what do I get? Give me the non-rounded answer. 1.0638 what? 29787. Now, are we going to report our final answer like that? Absolutely not, because we don't have a balance that can go that far. How many sig figs will I round to?
3.
Why 3? That's what my original number had, was 3. Look back at your original. So I'm going to look at these. The 3 is going to round down. So my final answer is going to be 1.06. Not grams. It's going to be moles of boron. All right, second one, we're going to go a little bit faster now. We're going from atoms to grams. It's going to be a 2-step problem. So we're going to need 2 conversion factors. The first one will have atoms of Ag on the bottom, moles of Ag on the top. 1 mole of silver has 6.02 times 10 to the 23rd atoms of silver in it. Then, over here, continuing along, moles of silver on the top, grams of silver up there. 1 mole. What's the molar mass for silver? It's like 107 point what? 868. Okay, when you do the math, what do we get for a final answer? You can round it. What's that? 0.01 grams. Is that correct, sig figs, though? That's what we should have, 0.014 grams. Remember, sig figs, that decimal right here, that 0 is non-significant. So when we have a decimal, we start from the left-hand side. Those are non-significant. It's 1,4 then is what we would have. Okay? We're going to keep practicing sig figs as we go along. Questions? Easy? Okay? We're going to do a lot of practice tomorrow with these conversions for our quiz on Friday. Now, what we're going to talk about, guys, is gram formula mass or molecular mass or molar mass. We've talked about this already when it's been one element. But what happens, do you think, when you have more than one element, like in a compound? What are we going to do to figure out the molar mass? Easy. It's the sum of all the masses. What does sum mean? Add. You're going to add up all the individual masses, guys, of all the elements in the compound. So here we go. This one, we need to figure out the molar mass of sodium chloride. And this is where naming, if you didn't master naming in the last unit, this is where you run into trouble and run into issues. It's going to be given to you most times in word form like this. You have to write the formula. If you don't have the right formula, because you don't know how to go from a name to a formula, guys, your molar mass is going to be off, and then every calculation from there on is going to be off as well. So it's crucial that you know how to name. If you didn't do so hot on your last test, you need to come in and practice some more. All right, so what's our formula for sodium chloride going to be? That's an easy one. NaCl. So before you guys just start going for it, one, you need to make sure you show all your work. You cannot just plug it into your calculator and be good enough with that. You have to show me it out. You need to write it out. This is the process, the way that I try to teach my students to do it. It's one that's going to make things easier later on. So here we go. What I'm going to do is I'm going to write out every single element that I have. So I've got sodium. I've got chlorine. Something we're going to learn tomorrow in class. If you do this method right here, it's going to make your life a whole lot easier with what we're going to. It's going to make it quicker tomorrow with what we're going to do. Okay? So we've got sodium. We've got chlorine. How many sodium atoms do I have in sodium chloride? 1. How many chlorines do I have? Okay? So this is my number of atoms. I'm going to multiply that by the molar mass of each individual atom. So what's the molar mass of sodium?
22.98977.
Chlorine is? Multiply those out. So this is my molar mass. And then this is going to be the total mass of each element. That's what we're figuring out right here. So this is easy math here, 22.98977. Down here it's 35.453. Now we're going to add them all up. All the individual pieces we've accounted for, add them all up to the total mass of our compound. So 22.98977 plus 35.453. What are we going to say our molar mass or gram formula mass is? 57.4 what?
4427.
Now, sig figs. It's 58.
Oh, 58. Yeah.
58. Sig figs. How many sig figs will we round our molar mass to? What did we do here? Did we add or add?
5 sig figs.
Why?
Because that's what the least amount of sig figs.
Okay. Also, we added and subtracted the least amount of decimals. Right here, it's 3, so we're going to round it to 3 decimal places. All right, this is rounds up. So our actual mass we're going to say is 58.443. Now, our unit, guys, our unit for molar mass. Molar mass. This is how many grams are in 1 mole. That's what molar mass is. It's the amount of grams in 1 mole of a substance. So our unit here for molar mass is grams per mole. It is a double unit. Okay? Grams per mole. Gets a little bit more complex now. Go ahead and write down all your elements first. I've got calcium. I've got nitrogen. And I've got oxygen. Figure out how many of each you have. How many calcium atoms do I have? 1. How many nitrogen atoms do I have?
2.
Why is it 2?
Because you have to distribute.
Absolutely. And that's the piece that will trip some people up. You've got to multiply by 2. You're going to distribute that outside the parentheses. Again, a classic example why we keep polyatomics in parentheses. All right, or for these examples right here. How many oxygen atoms do I have? 6. If I asked you how many nitrate ions I had, how many would I have? 2. Good, okay. Mass of calcium is what? 40.08. That's easy math. So it's 40.08. Nitrogen is going to be? 14.0067. And oxygen is going to be? 2 9s and a 4?
3 9s.
Okay. Yeah. All right. Nitrogen, what's the total mass nitrogen brings? 28.0. Oxygen's going to be? Okay. All we have to do then in the end, guys, is to add all this up. When you add 40.08 plus 28.0134 plus 95.9964, what do we get for our molar mass?
64.
How many decimals will we go to here?
2.
Why 2?
Because 4.08.
Absolutely, guys. So for sig figs, when we do this, you're looking at the least number of decimal places of any of your numbers there, and that's where you're reporting your final answer to. So this is going to be 164 point what? 09. And what's my unit going to be?
Grams per mole.
Grams per mole. That's a terrible looking G. There we go. That's my final answer. Grams per mole. Our definition of molar mass is the number of grams per 1 mole of a substance. This is what we will measure out in lab. Next week, you guys will be doing a lab where you have to do this. All right? Your homework tonight then is page 4, numbers 1 through 8.